Hello, my dear students. I am Mukesh Tilwani, Assistant Professor in MLV Textile and Engineering College, Pilwara. The subject is manufacturing processes, and the topic for today is welding process. This is the lecture 1 of the welding process, in which I will discuss about what is the welding process and basics of the welding process. First, what is welding process? Welding process is the process of joining the similar and dissimilar metals with or without the application of heat and pressure. This is a process in which we can join two metals. We can join two metals with the help of heat and pressure, with or without the help of heat and pressure, and we can join similar or dissimilar metals. The metals are different in properties, or can also be welded, and the metals which are different in shape can also be welded in welding process. First, talk about the weldability. What is weldability? Weldability is a property of a material for welding process. The welding process of the metal depend upon the various factors like metallurgical changes that occur due to the welding, changes in hardness in and around the welding, extent of oxidation, and the extent of cracking. The weldability property is depending upon the metallurgical changes in the material. Due to the metallurgical changes, the hardness at the different point of the metal are different. At the different the hardness is different zone is different, and we get the cracking at different zone. So we have to know about the metallurgical changes while applying the welding process for joining the two metals. First, metallurgy in welding. What is metallurgy used in welding? Metal is heated over the range of temperature up to the fusion and followed by the cooling to ambient temperature. For joining the metals, the temperature ranges from fusion to ambient temperature. If we proceed to the joining process, during the joining of the metals, the temperature is at the fusion. After joining, the metal is cooled up to the ambient temperature. Because of this differential heating, the material far away from the weld bead will be simply warm out, but as the weld area is approached, progressively higher temperature is obtained, resulting in the corresponding complex structure. First, we have to know about the bead. What is bead? If we join two metals, these are the two metals. First one is this, second one is this. If we join two metals, we heat two metals and give the pressure to the two metals, and use filler material for joining the metal. We get the one zone. If we join two metals, this is a primary zone where we got. This is a we can say this is a liquid zone. Due to this zone, we get the property different at different area. So after joining, we form one zone which is called the bead. This bead zone can be the fusion zone. After cooling, we get the up to the ambient temperature. And if there is a differential heating there, in the base metal the temperature is different. Here in the bead zone the temperature is different. This is a liquid zone, as we can see from the point C, that melting point of the base, and this is a point A. This is a temperature gradient curve. I will discuss later. Due to the temperature changes and differential heating, we get the different microstructure at different points. The heating and cooling also results in setting up the internal stresses and plastic strain in the welding. So at high temperature, physical, chemical and metallurgical property can be liable to change. Due to the temperature changes here from bead to heat affected zone, this is a solidification zone, this is a liquid zone. There is the temperature difference is there. Due to the temperature difference, internal stresses are developed in the metal. Due to the internal stresses developed in the metal, we get the different physical properties at the maximum temperature zone, and we can also get the different chemical and metallurgical property at the maximum temperature zone. This is a maximum solid zone, which is maximum temperature zone, and depending upon the welding process used and the metal being welded, there exists wide variation in the maximum liquid temperature and in the slope temperature gradient curve for the unfused metal. This is the unfused metal, and this is the fused metal. Fused metal is divided into two parts, which is bead and heat affected zone, and unfused metal is base metal. Therefore, we divide this into three distinct zones, which are: first one is base metal, second one is heat affected zone, third one is weld metal. This bead is a weld metal, and if we go outward, we get the heat affected zone. If then we go outward, we get the base metal here. So we in the joining process, we divide this complete metal, joining metal, in three different zone, which are base metal, second one is heat affected zone, third one is weld zone. The different we get the different property at different zone. So here we can see that temperature gradient curve at different zone. In base metal zone, the gradient the curve is gradually, temperature is gradually increasing if we go forward to the up to the bead point. After reaching the heat affected zone, the slope of the curve is increasing, and after reaching the point C, we get the melting point of the base metal. Here, after heating, the metal will melt, and we get the joining of two metals here. A joint produced without the filler metal is called autogenous, and its weld zone is composed of the resolidified base metal. We can join the two metals by using fillers, or we can also join the metal by not using the filler metal. If we use the filler metal, we have to heat the filler. We have to use the heating, and for if we don't use the filler metal, we have to use the give the heat to base metal and give the pressures so that we get the joining in of the metals. If we don't use the filler metal, then this bead zone instantly resolidifies. But in the filler metal, if we use the filler metal, where we are at the fusion zone, then gradually after cooling up to the ambient temperature. Now talking about the metallurgical changes in the microstructural changes in the bead zone. The central portion of the bead will be cooled slowly. Long columnar grain will develop, and in the outward direction, grain will become the finer and finer. As we can see from the diagram, that at the central zone, this is the central zone of the bead, we get the coarse grain properties here. Due to the coarse grain properties, the strength is strength is lower and ductility is higher. This is a curve shown the ductility property and strength property at different points. If we are at the central zone, we get the columnar coarse grain, and if we go outward direction to the bead, we get the different grain changes. Here we get the finer grain, and here we get the more finer grain. So the properties at the different point in the bead are different. If we go outward, the ductility changes, and strength and ductility property are changes. So the ductility and toughness of the bead at the center will be higher. Thus, the original structure consisting of ferrite and pearlite in steels is changed to another microstructure. Now the classification of the welding process. First I have to discuss about the weld zone again. The weld metal, when it is in the molten state, has a good capacity to dissolve gases which come into contact with it, like oxygen, nitrogen, hydrogen. As the metal start cooling, capacity of dissolved gases goes on increasing. Goes on decreasing, thus causing additional volume of gases to be involved. Due to the appearance of the meshy zone during the solidification, a portion of these gases may be trapped into the bead called porosity. This decrease in strength of weldment. As we can see from the diagram that the strength is going to increase from central zone to, if we go outward direction to the heat affected zone, the strength of the metal is going to increase, and after we reach to the heat affected zone, the strength is constant. And what about the ductility property at the central zone? For if we go outward direction, first the ductility is going to increase, and if we reach the if we get the finer grains, here the ductility is more, and if we go go outward direction, the ductility is going to decrease, because here the toughness is going to decrease of the metal. Now the classification of welding process. We are characterize the welding process in different types. First one is arc welding, resistant welding, solid state welding, radiant welding, thermite welding, allied welding, gas welding. We discuss all type of welding in another lectures. For today, I'm closing. If you have any doubt or query, you can comment. I will give the response of your comment. Thank you so much.